First of all, thanks for joining tonight. The talk tonight is about Angular performance. And it's about Angular specific performance measures, so it's not a general talk about web performance, but about specific measures when you're dealing with Angular. I want to show you some common pitfalls and how you can avoid them. That's the basic idea. Before we dive into that topic, I'd like to quickly introduce myself. My name is Christian Liebel. I'm a Microsoft MVP and a Google GDE in the JavaScript categories. I'm working at Detector, and we are focusing on cross-platform development, which is my part, and colleagues of mine are focusing on serverless cloud architectures. If you want to follow me, I'm on Twitter, just Christian Liebel, lowercase and in one word. Blog is christianliebel.com, and if you have any questions afterwards, maybe on your way back or next week when you're talking to a colleague, then feel free to send me a tweet or an email. Email address is christian.liebel@thinktecture.com. So that's my offer to you in case you have any questions after this talk. As I've said, today I want to talk about Angular specific performance measures, and there are two different sites that we want to have a look at. The first one is runtime performance. So that's the performance type when your app has been downloaded from the server and is then being executed in your browser. And the second part is load time performance. So that now is about how fast your app can be downloaded to the client, to your browser. All right. So before we start, I want to talk about the first rule of doing performance optimizations, and that is don't over-optimize. If you don't have any problems in your application right now, it could just be fine. Then just leave it as it is and don't try to start something that won't help you in the end. So my suggestion is to just keep going, and only if you've stumbled upon some performance issues, you should have a look at why that is happening. But of course, it's always a good idea to see what can go wrong so you can react accordingly. All right, so now let's have a look at runtime performance. And as I've said, there are some general aspects what you should do in order to improve runtime performance is reducing computations during runtime. So that means you should reduce calculations. You shouldn't calculate something that you don't need, for example. You should reduce paints, and you should reduce layouts, for example, because that is expensive. Also, you could introduce some CSS tweaks or JavaScript tweaks that are twice as fast, maybe, but that's also not part of tonight's talk. And there are lots of performance metrics, for example, time to first byte and so on, which is also not our topic tonight. But instead, now we will start looking into the Angular-specific runtime performance topics. All right, so Angular's runtime performance is highly related to change detection. Change detection is an automated mechanism which you can hardly control. It's something that is just there, which is very powerful and magical, but you should understand what it actually does, because change detection can also work against you. All right, so let's start with a little overview. On the left-hand side, you can see a template of an app component, and what I'm using here is the mustache syntax, a classic data binding, and what I want to do is bind the title field from my component class, which you can see on the right side of the screen. And when you look at that, and when you would run that and execute it in your browser, obviously what you would get is high Angular, because Angular is interpolated here into those brackets that you can see. For that scenario, you wouldn't need a change detection system, because this is something that a classic templating engine could do for you, right? For example, something like Jekyll or Handlebars would exactly do that. It's just interpolating fields from an object to a template. That's the idea. All right. Now let's have a look at the next step. Imagine it's not only that static title, but we now have a button. Here you can see it. It has been added to the template, as you can see. And when we click that button, it calls the update method, which we can find on the component class again. And there you can see that the title should update to foo. So what's the result when I hit the update button here? What will we see then for the title? Hi foo. Exactly. So when we click it, then it says hi foo, and that's essentially it. And that isn't surprising at all, right? So that's the way how Angular works. But that's also the mystery. So why does that work? All you did was to reassign the value of the title field. The title field that has no specific decorator or something, right? It's just a field. How can we attach to that, and how does Angular notice that there was a change? That's the question. So change detection is that magical part of Angular that makes your data binding just work, right? So for example, clicking update and seeing hi foo as the title. And of course, it's a very handy feature, but as I already said, it can also work against you when you're dealing with it the wrong way. And it's strongly tied to your Angular application runtime performance. Now the question is why. When you build an Angular application, typically what you have is a component tree. So there will be mostly one single app component. You could have more than one if you like. And that app component uses different other components. Here in that sample you have a nav component for navigation, a content component, and the content component makes use of a list component. That's your Angular application from a bird's eye perspective. Now, what you don't see in behind is that there's a change detector tree, which basically shadows your component tree. So for each component that you have, there's also a matching change detector. And that essentially shapes the same tree. Now, let's imagine there's a change now, somewhere in the application. What happens next is that we will now run those change detectors, right? And we do that in a certain way. We start at the top and then go all the different change detectors down until we hit the last one. So one single time, top to bottom, there are no cycles, it's in one direction. What happens here in behind is that Angular now calls the so-called detect changes method of all of those different change detectors, and what then happens is the following: that we will now interpolate the values of a class field, for example, let's say foo, and update that data binding in the template. What you can see here in behind is the detect changes method of a change detector of a component. And so this is called whenever there's an event or a change happening, so your data binding should update now. Now, by default, each change in your application, whatever you do, leads to a change detection cycle. A single one. Mostly when you're during development, there will be two change detection cycles, but in production it will be one single change detection cycle for each change, again from top to bottom until we have checked all components and in one direction, so no cycles. That's the default behavior. And so what that means is the following. I have a little demo for you. All right, so I hope you can read it, but I think it looks quite good, right? Okay. I have an app component, which consists of two other components, comp1 and comp2. And what I want to do is just add a little a border around that so we can see which component is which. Or let me put a div around that with a border of 3 pixels, solid green, for example. That's for component 1. And then 1 in red for my component 2. Now, my component 1 says there's a default text comp1 works, and it has a button with a click handler, and that click handler does nothing. It's just a dummy. It's just true, yeah, that it evaluates that, but that's it. That's component 1. And what component 2 does is it has a data binding to a field called foo. And when we have a look at the component class of component 2, we can see that foo is a getter, and it will always return foo. But when I read from that property, we will also log foo read to the console, so we know when that getter was accessed. Okay, here in my browser I have that demo application running. It is here, and we can see the green box, which is comp1, and the red box, which is comp2. Now, as you can see, foo read already was called. So someone accessed that already during the setup of the app component. Now you can see there that foo read always appears twice, and that has a reason. And the reason you can see here. Angular is running in the so-called development mode, and that means that Angular will perform change detection twice. And between those 2 change detection cycles, Angular will check if the results of those 2 change detection cycles are still the same. If they aren't, then some logic is running in your application which Angular can't detect or which Angular can't see. And that could lead to potential out of sync scenarios in your application. So that's why the development mode always does this double check and then compares if the result is the same. If it isn't, you will see a very famous error. Can change expression since has been checked. I don't know it by heart now, but all of you know it, right? That's caused by that development mode. All right. So as you can see, we have 2 components which are now on the same level. So component 1 is on the same level as component 2, and there's only app component around it. So what do you expect? What happens when I click me? Okay, it might be pretty obvious. What do you think? What will we see? Okay, little quiz, little show of hands. Who of you thinks that there will be no console output? Okay, some. Who of you thinks it will? Okay, awesome. Right, because that's already the idea, right? So if we click me now, you can see that now foo is evaluated. And that's might be surprising because there's no reason actually to read from foo because that's an entirely different component. This click is entirely local. So as you can see, one change leads to an entire check of the entire application. All right. So what does that mean? Whenever you have a change in your application, your entire app will be checked. So your interest should be to keep the duration of a single change detection cycle as low as possible. So for example, you shouldn't have too many bindings on your page. Now let's say you have 10,000 bindings because you have a really huge grid. One change detection cycle can take very long in that scenario. Right? So you should try to reduce that amount of data bindings that you have. For example, next time the CDK talk, right? Angular CDK has a virtual scrolling mechanism which you could use to reduce the number of bindings during runtime. Right, and as you have also seen, you should avoid binding to getters or to functions. You can also bind to functions, right, or to function or invocations, which is fine. And you should make sure that they don't take too long. It would be very critical if the function that calculates your name, for example, takes a second, because that function would be executed for each change in your application. Our suggestion is to keep your change detection cycle lower than 16 milliseconds, because that's one flicker of your screen, so to speak, and that makes sure that your application feels fast and fluid. If you want to measure, oh sorry, that's a question. No, sure.
My question was, how do you measure that?
Yeah, exactly. Great. Thank you for that question. The question is, how do you find out how long your change detection cycle takes? There is a profiling tool which is provided by Angular. However, it's not enabled by default. If you want to enable it, you have to go to your main.ts. And after the bootstrap module call, you can then enable debug tools. Now it's a bit complicated because you need to stuff a component in there, right? So basically that's something that I always copy from that slide because it's difficult to learn by heart. So you can just add it to your main.ts, and afterwards you have a little profiler tool on your console, which you can find on ngProfiler, and then there's the method time change detection. And what this method does is it measures the duration of one single CD run, and it does it for either 500 milliseconds if your CD cycle is faster than that, or it stops after 5 change detection cycles if your CD cycle is slower than that. 500 milliseconds for a CD run would be horrible. Now let's have a little demo of that. Here we are. As you can see, I already added that line to my main.ts, just that single line after bootstrap module, before catch, and that enables my debug tools here. And now you can just enter that to the console, so ngProfiler, time change detection, and now we can see that the change detection is running. You can also see it because our foo red console log is appearing again, because that's invoked for each CD run. And here at the end you can see the summary. So this one ran for 500 milliseconds, and in that time we were able to do 1464 CD cycles, and that makes 0.34 milliseconds per check. That's a very good value. Of course, it's also only a getter right now. Yeah, it's only that single one. So typically you won't have this awesome value in your application. Right, but as I've said, try to keep it as low as possible. So that means try to use as few bindings as possible, and to make them not too computationally intensive. Alright, so that's the first part. Now we want to have a look at the topic from the second part, from the other side. So one problem is we are getting calls too often. Now the question is, when is something being called, right? So what triggers that change detection cycle? And therefore we need to have a look at Zone.js and at the NgZone. The question is, who or what triggers this change, and then finally that change detection cycle. And if you have a look at Angular's dependencies, I'm pretty sure you've already stumbled upon the Zone.js entry. Now, Zone.js is a library which is provided by the Angular team, interestingly. That's something that they have created. It's of course also open source, and you can find it on GitHub, and it's in the Angular organization also. It's pretty hard to define what Zone.js actually is. If you look at the GitHub repository, you will find two explanations. The first one is Zone.js is a meta monkey patch. Okay, so a monkey patch is something that attaches to something different during runtime, and it's a meta monkey patch, so it's for everything. And the second one is it's an execution context for asynchronous JavaScript. And what that means we will see in a minute. So let's first talk about that meta monkey patch stuff. Zone.js is a library that tries to detect whenever something is happening in your application. And in order to do so, it attaches to set timeout and set interval, for example. Basically, Zone.js just overrides those two methods with their own implementation. So they know when your call is being executed and when it is finished. And so that way, Zone.js knows if there's still work that has to be done and when that work happens. And of course, that not only works for set timeout, but also for set interval. Apart from that, Zone.js attaches to any event that is being fired in your browser, so click, focus, whatever, literally. And it also attaches to some web interfaces. For example, if you're using the geolocation API and your position changes, then Zone.js knows it. When you're doing an XHR request and it returns, then Zone.js knows it. When a promise is being rejected, Zone.js knows it, and when you're requesting an animation frame, Zone.js knows that as well. And that's only a little glimpse of what Zone.js actually touches. Now there can be a problem if you are using interfaces that are not being covered by Zone.js. In that case, your application can get out of sync because nobody is then triggering the change detection cycle. And that typically happens if you are using Apache Cordova, for example, for mobile applications. They are using events which are not being covered or not even being seen by Zone.js. And that means in those cases, you need to trigger change detection yourself. All right, so meta monkey patch part. The second one was execution context. Now, as I've already said, Zone.js now knows if there are pending operations and when those operations are being executed. So you can use Zone.js, for example, for debugging purposes. Because when closing an application, you can, for example, tell that there are 3 open tasks, for example, which should be completed at first. Then you can use it for profiling purposes, for example. You can now time how long such a set timeout or set interval call, for example, takes. There's also a plugin for Google's WTF, which stands for Web Tracing Framework in that case. And you can just plug those two together, and then you get a nice profiling for your app. Also, it's great for mocking and testing purposes. Because now that Zone.js has control over set timeout and set interval, it can just, for example, remove the duration. That is great for testing. Imagine you would have to wait 10 seconds for your unit test to complete just because you're using set timeout. In that case, Zone.js just says, okay, the 10 seconds are over now, and your unit test goes through in a couple of milliseconds. So that's what Zone.js is for, and that's why it is in Angular itself. Zone.js attaches to your entire JavaScript context. So it basically grabs control of your entire website that you're hosting it in. Now, that's the first part. And when your Angular application is starting, Angular will create a fork of that global Zone.js context. So when your application is booting, we are creating a fork of that global zone, which is typically referred to as the NgZone. And now everything that happens inside Angular, so essentially everything that happens inside that bootstrap module call, right? That is where the zone is being spawned, will now happen inside that NgZone. And not on the global zone per default. So the idea is, per default, Angular knows everything that happens inside your application. Alright, and now that's the way how Angular change detection works for asynchronous operations, for example. The NgZone catches anything that happens in your app, set timeouts, at interval, at XHR requests, events, and so on. And whenever such an event is being raised, then Angular will immediately respond with a detect changes call on your change detector, which we have just get to know. When does the zone do it? It does not do it for any set timeout call that you send to it, but instead Zone.js checks if there are open tasks for the current VM turn. And only if the current list is empty, it will then trigger one change detection cycle, which is also referred to as a tick, which you might also have seen in other contexts. Yeah.
So I assume the change detection is called when set timeout returns them.
Yes, and if there's no other work that has to be done.
Yeah.
Right. And now, essentially, that's a quick intro to completely understand change detection in Angular. Here's how it works. NgZone has a hook which is called onMicroTaskEmpty. So that means everything that I have to do now is done. Then we are calling application.ref tick. Pretty sure you've seen that already. And what application.ref tick does is then inform the different views. That's an internal term for your component, and will then call detect changes on it. We've already met that guy. And you can now even understand that when you have a look at the source code. So here's the link to application.ref, and that's where the Angular change detection magic is happening. Let's have a quick look. So on microtask_empty is the hook. Then we are calling the tick method, and it's a tick method of the application ref here. Now let's quickly search for that. Here it is. And what the tick method does is just loop through the different views and then calling detect changes on it. That's the Angular change detection. All right, so what could be a common pitfall now? That could happen if you have, for example, long CD cycles as a first part, but also high frequency events. Because as you have seen, Zone.js attaches, for example, to mouse move. So that means for every move of your mouse cursor on the screen, if you bind to that event, it attaches to scroll, which can also be very expensive. Especially for smooth scrolling. It attaches to request animation frame. Request animation frame is designed to be called as often as your screen is refreshing. So that is 60 frames per second. So if you're using 3D visualization, 2D visualization, or for example data with a high resolution, then your change detection is called with 60 FPS, for example. Or you could also have a set interval with a very short interval. For example, if you have a clock in your application. Does someone of you have a clock in his or their application? No. I was surprised how many applications have a clock, really. And that's a typical problem, because now that clock ticks every second, and so for each second you perform a change detection run. You check the entire application again. And now it's 20 o'clock, 10 minutes, and 21, and again, please, right? So that obviously doesn't make sense. Let's have a look at that in a quick demo, which I prepared here. Just have to reset that. Demo 2. All right. Now let's see what I've changed here. I have added a host listener to my component 1, which now attaches to document mouse move. And still component 2 is unchanged. I have that foo binding, and we also have that foo getter. Now I go back to my app. Here it is. And I will move my mouse across the screen. And now you can see it as the scroll bar gets smaller. Unfortunately, yeah, let's try it again here. Now you can see it, right? And so now for every move of my mouse cursor, I will re-evaluate that foo again. So the question is, why does Angular do that now? Aren't they clever enough to figure that out? The problem is, what would be if there is a certain side effect? What would be if you show the mouse cursor coordinates here, for example, in your application? Angular can't detect that, and thus, per default, tries to protect you from getting your view out of sync. So that model is, the default model makes sure that your view is always in sync with your data model in behind, but it's also expensive for certain operations, as you can see. Alright, so what happens here now is there's a mouse move event and Angular reacts with detect changes. Mouse move, changes, and so on. Now, in that case, where I only attached to mouse move, or where I have my clock that ticks every second, or in a case where I have a 3D visualization that changes nothing but the visualization itself, I want to avoid that detect changes call. So, how can you avoid it? You can get a reference to the NgZone by just injecting NgZone to your component or whatever. And on that NgZone, there's a method called run outside Angular, which is where you would run performance critical code in. And if you want to change something, if the 3D visualization once in a while needs to update something on the view, you can then use NgZone run to jump back inside the Angular zone when you have exited it before. Again, the problem is, if you're using run outside Angular and would now change something on your component, for example, now the change detection would not see it and would not update your component. So that's why I put that little exclamation mark here. Using that can lead to your view getting out of sync with the model. Alright, but the effect of it is the following. The mouse moves now only go to the global zone. The global zone has no idea what Angular actually is, so there's no change detection happening afterwards. And I want to quickly show you that in the next branch. So what I did here now is rewrite that host listener that we've just seen. And what I do here is using the renderer, which allows me to also listen to events in a very nice manner. So when I want to respond to the document mouse move event, I just say document and mouse move. The listener again does nothing. And now I wrap this call inside the run outside Angular method. Right? So now in that case, it is being executed in that global zone. And now let's switch back to our application. And now I move my mouse cursor, and as you can see, foo is not evaluated now. So no change detection cycle is running in that case. What I've just shown you, is very typical, because typically you will have some visualization or some high resolution events in your application. So that's why in your polyfills.ts you will find this line. Maybe you've seen that already and wondered what could that be for. If you want to disable the Angular zone for request animation frame calls, so data visualizations, for example, then you can just flip that property to true. Also, you can disable it for certain events, so for all on property attributes. And there's also a blacklisted events, because if you want to disable the zone for scroll and for mouse move events, you can just add them to this line in your polyfills.ts, and then change detection will be disabled for it. However, remember, if you do that, it's disabled for your entire application. And I also had that case already, that someone wanted to respond to mouse move, and now it didn't work. So always remember what you turn off, and it's better to do it locally, right? So to use run outside Angular when you are sure that you want to run outside Angular in that specific case. More than that, you can decide to disable the NgZone entirely, because in the Bootstrap module call, there's a configuration object, and when you give no opt for the NgZone property, then the Angular zone is disabled entirely. And what you then have to do is call the change detection yourself, which is something I wouldn't do, and I've seen nobody who would need that, but who knows? Maybe your application needs that. Just think about that. Your application will definitely be out of sync until you're calling the tick method. And then you know what happens afterwards, because we are checking the change detectors again. Okay. So now we've seen the big problem. Change detection cycles that are too long and calling change detection too often. How can we avoid that apart from things like scrolling, mouse move, request animation frame, and so on? How can we avoid that our method is being checked for no reason? This is where change detection strategies come into play. The default is the following. Default is we are using Zone.js, and whenever there's a change in your application, we are checked with the entire rest of the application. If we want to avoid that, there is the so-called OnPush change detection strategy, and that says I only want to be checked when there was a change of my input parameters. So add input decorator and a field behind it, and whenever the view updates this field, then and only then I want to be checked as a part of the change detection cycle. So when you're using OnPush and there is a global change, typically you and your subcomponents will not be checked anymore. It's pretty easy to implement that. You can just add the change detection field to your add component decorator, and then pass the change detection strategy OnPush to it. And then again, don't forget that now your component will only be checked if that foo property is updated from the outside. That's also important to know. The view has to update that foo parameter, and then the framework will take care of the rest for you. So make sure to have a foo input, which is the only one, or which are the only ones, if you have more than one, that can have an effect on your component state. And if you use it, your component will only react to changes of this input parameter. Don't forget that Angular will compare those values using a strict equality. So that means if you are passing an object to it and the object instance does not change, Angular will not update, because it's the same instance of this object, so I will not check this method. So in that case, it makes sense to use immutables, for example, and immutable objects to make sure that you will get a new instance of that very object. So that's important. And again, don't forget, this scenario can lead to getting out of sync. Quick demo for that one. All right, so now let's check it again. My component 1 again reacts to document mouse move. So now foo should originally be called for each move of my mouse. But this time in component 2, I've adjusted the decorator to now be OnPush. And as you can see, this component has no input property. That means that this component will only be checked once for the first time when it's being built, and afterwards never again. And when we switch back to our app, we can see it. I can move my mouse, and foo red does not appear anymore. All right, so the next question that arises then is, how do I now inform change detection when I have an internal change? So when I received something and I now want my component to be checked, although I'm an OnPush component. And that could be a data service, for example, that pushes updates to my app every second, for example, or those are financial data, for example, so it's nearly always that this observable is being executed. Then when I would do nothing and I would change the data field in that case, then the component would not update, obviously. Alright, so now how can we explicitly request this update? Let's have a look at the ChangeDetectorRef. ChangeDetectorRef gives you access to the change detector which is responsible for your component. So if we think about that picture again, it's the one that matches our component. So we get that by calling or by requesting ChangeDetectorRef. Detect changes, we already know that. Detach, no. Check node, no. Also not that. So it could be mark for check. And that's essentially it. So if you want to explicitly request a change detection cycle, that's not entirely true. If you want to be checked on the next change detection cycle, you can just call mark for check on your ChangeDetectorRef. And so in that case, when you typically would not be called because you are an OnPush component, but then call mark for check, you mark your component as dirty and you will be checked during the next CD cycle. So that's how it would look like. You have your data service as a first injectable. Now you inject the ChangeDetectorRef as well. And whenever you update your component now, you are calling mark for check, and then everything is fine again. Keep that in mind for a moment. Because next I want to show you the other two methods that we've just seen, which is detach and reattach. Using the ChangeDetectorRef, you can entirely detach from change detection. So that means whenever something happens, regardless of OnPush, you will never be called as a part of the CD cycle. So let's imagine there is one, you will simply be skipped. You are no part of the CD cycle any longer. And using reattach, you can then reattach to the CD cycle, so for the next one you will be called again. That allows you, or those two methods allow you, to do change detection entirely locally. So that way, these are cases where you really rarely have to update your component, or you want to detach it for a while because it's not visible on your screen, right? Imagine you have a window with 200 data bindings, which is only visible for a short period of time. Then you can just detach it for the time where it's not being visible on the screen. Again, this can lead to your view getting out of sync. Yes?
What happens to subcomponents?
Those are detached as well.
Okay.
So here's also a little example. Detach is the first call. If you want to do a particular single check of your component and its subcomponents, so it's downwards in that case, you can call detect changes again. So you still have it under control. And if you want to reattach to the tree, as you've seen, you can do it using reattach. Two questions, yes?
Mark for change detection, it will work only once, and after that again it will be skipped for the next cycle.
Mark for check only marks me as dirty for now, and so that means for the next cycle. 2, 3, yeah.
Okay, so I want to know, so for every action there is checking changes. So if every action takes too long, for instance, it's like a queue, queuing all the actions.
Yes, that can happen. And typically in those, we see that scenario when you try to, with one application, for example, where you also move some boxes around the screen, for example, it can then happen that your application freezes for a moment until that backlog of operations has been successfully processed. And only then you can drag the next box. Okay.
You're going to show the async pipe too?
Yes, exactly. Right, so that's an example for local change detection. Okay, so what have we learned so far? We should reduce the amount of change detection cycles, right? So that means by, for example, disabling Zone.js entirely, which typically is not the best idea, by opting out of NgZone where it makes sense. I think that's a good approach. You could disable certain operations entirely using polyfills.ts where it makes sense. And you could use the OnPush strategy, which I use as a default. When I create a new Angular component, I directly make it OnPush. And that also helps you build your components to be dependent on the actual input and not so much on service inputs, for example. All right, and you can do local change detection where it makes sense. There are cases where that is suitable. All right, now here was the question. There is something called async pipe. Why is this async pipe so sweet? Why does it make sense to use it? I'm pretty sure you've seen that already. The async pipe has a lot of advantages. What the async pipe does is you are now binding to the observable itself, for example. It could also be a promise. The async pipe also supports that. And what the async pipe does is it subscribes to the observable for you and then waits for an update, for example, of that observable or for the resolve of the promise, and will then display the value. One of the huge advantages is that you don't have to remember to unsubscribe from that observable, what you should do, obviously. And so that's something that is handled by the async pipe. So the async pipe subscribes for you and unsubscribes for you. But that's not the only thing that the async pipe does for you. It does a little bit more. Because what it also does, apart from subscribing and unsubscribing, is calling mark for check for each update of that observable. And so that makes it a perfect match for the OnPush change detection strategy, because now you can just get rid of this injectable of ChangeDetectorRef. You don't have to remember to call mark for check. That's what the async pipe does for you. Let's have a little, or let's check that in the Angular source code. Here is the async pipe. Oh, it's even open here. And let's find it. Here it is. And then we just have to check or to search for the mark for check call, which is being invoked on the ChangeDetectorRef. Really great. Yeah, saves you 2 lines for each observable, which you would have to typically use. So again, that's my default. I'm using OnPush as a default change detection strategy, and then rely on input properties, and where I have to use observables, I'm using the async pipe. All right, and now here's a complete example. As I've said, you do not need the import anymore. So the injecting the change detector ref anymore. You can just bind the observable here to a field on your component. It's best practice to bind to observables in ngZone init. I'm pretty sure you know that. The reason is that it's easier to test, for example, because you don't have to arrange fake observables. But that way, it's now pretty easy. You can just put that into the constructor because it's a synchronous call, and you have only to make sure that this updates property is there. It wouldn't even hurt if it's not there, because then this field is just undefined, right? So synchronous assignments can just happen in constructor, so you can even leave ngZone init out. And on the component side, you can just add the async pipe, and then this whole thing works using OnPush. All right, so that's it for the runtime part. Okay, we've seen the different approaches, and we've seen what can make our Angular applications slow. When I've seen slow Angular applications, it's always related to this, what I've just shown you, to the change detection cycle, and typically to scrolling, mouse move, and so on. All right, now let's have a look at load time performance, which is the second part of it. Again, what I will not cover is mechanisms like HTTP to push or HTTP to multiplexing, which allows you to send responses to your client more efficiently. That's a different topic. Also, I'm not going to talk about compression like Brotli or gzip or whatever. That's also a different topic. Again, we want to have a look at Angular specific things. And with special focus on reducing the initial load, so that means the size of stuff that has to be downloaded and computation which has to run, then to reduce the perceived loading time, and to prevent downloading the same resource again. There are different approaches to achieve that, and I would like to start with bundling. Now, here's the problem. If you have a look at your Angular development directory, obviously it's a bad idea to just use that and ship it to a server and execute your app from there. Why? Because you have a whole bunch of different subdirectories. Of course, some of those files have to be transpiled before your for a browser or your client can actually run them. But those many directories would be hard to deploy. There's slow protocols which have some overhead for a single file, and they're hard to serve, and they're hard to cache because now it's a whole bunch of stuff. So you have lots of files, lots of requests, so obviously that's not the way how you ship your application. Instead, what you are doing is run the ngbuild command before shipping your Angular application, and then you get a build. However, there are different commands or different parameters for that ngbuild command. And when you're just running ngbuild, you of course get a bundle, but this bundle has a little problem because there's Angular in it, and Angular is pretty huge. And your app typically only uses a little fragment of that huge library. So we want to get that app bundle a little bit smaller. When you're using just-in-time compilation, that's most horrible because just-in-time compilation means that your client has to render the templates on the client side. And that may be slow. For example, on mobile devices, it's very slow. On desktop machines, it may be okay. But still, for just-in-time compilation, you need the template compiler, which has a neat little 1.2 megabytes in size that you have to transport to the client beforehand. Then you can only detect template errors during runtime. I'm not sure if someone of you did VB6 or Visual Basic in previous versions. You only found errors during runtime when you just by accident found the form that in that scenario doesn't work, right? So that's also not great. And it also may be potentially dangerous because there could be injection attacks. You could modify those HTML files on their way down to the client, and then you could modify them. So just-in-time compilation is also not that great, as you can see. It makes sense, for example, for debugging purposes because it's pretty fast. You don't have to compile the entire application. Instead, you only compile what you're actually using. So JIT is fine, but rather for development scenarios. And what we would now like is an Angular app that has all components pre-compiled that are combined in ideally a single file. For practical reasons, it's not that way. You have a couple of files, but it's only few. With all of the redundant, unused code removed, and which is uglified and compressed, so that your competitor can just open it and see, ah yeah, that's the way they've done it. That's our goal. So how do we achieve it? What you can see here is the JIT approach. So you have your component class, you have a template. They are both transferred over to your client, and the client will then create the view class for this combination. That's how JIT works. Now, when you're using ahead of time compilation, which is part of ngbuild-prod, for example, we will then shift that process here, basically deducing the template, we will shift that over to the server. So we will here create a view class and then only transport that over to our user. That's called AOT. It's nothing new. A couple of frameworks have it, but essentially that's the idea. And of course, we can now just drop this 1.2 megabytes compiler, so our app bundle gets a whole bunch smaller. But when you're running ngbuild-prod, that's not all of it. There's more. So AOT is one first effective measure, but apart from that, what the Angular CLI will transparently do for you is something called tree shaking. What you can see here is the original definition of what tree shaking does in the Angular documentation, and there they said it walks your dependency graph from top to bottom, and then it shakes out unused code like dead needles in a Christmas tree, which I think is a very nice explanation for it. So essentially it checks which imports you have, which exports you have, and if there's files that don't get imported, for example, then we can just remove them from the output. And that again makes our bundle a whole bunch smaller. Then we have the so-called build optimizer that applies some code optimizations, which then makes it easier for uglifiers to minimize that code even better. Now, as a little overview, here we can see it. A typical dev build is 4.2 megabytes in size, so that's just in time. AOT is really small because that compiler is just not required anymore. When we tree shake that, it even gets smaller because we throw out a whole bunch of Angular that we don't need. And if we build optimize that, we come down to 379K, and if we cheese it that, it's only 106K in size. Now, for all of you that are using Angular CLI 7.3 or maybe even Angular CLI 8, what is being integrated there is so-called differential loading. That means that Angular will detect your platform and will only deliver those files to your user or to your client that are suited best. For example, if you are using IE 11, this browser does not understand ES 2050. So if you would compile it to this version, it won't run in IE 11. However, ES 2015 is far simpler to write, because, for example, you have fat arrow functions, which are per se smaller than function and then the brackets, right? It's just smaller in size, and we would like to use that and deliver newer files to newer browsers. So in Angular CLI 7.3.0, the polyfills are delivered in an ES5 format and in the ES 2015 format, and for modern browsers this saves another 56 plus K. Here you can see how that works. No module is a marker for new browsers, and when they understand the so-called module syntax, so to speak, they will not load this file. And instead, they will only load those files which it actually needs. Alright, now starting from Angular 8, the CLI will create two builds of your application, one for ES5, this is larger and for IE 11 and other legacy browsers, and one for ES 2015, which is smaller and suitable for more modern browsers. And so your user gets a smaller bundle if it has, they have a modern browser. Okay, now lazy loading. I'm pretty sure you know that. The Angular router supports lazy loading, and that means your user only has to download parts of your application that the user actually needs. And in Angular, this is done using the router. You can define that some of the routes should be lazy and lazy loaded. And so they will not be loaded on boot, but only when your user needs them. That's how it looks, starting from Angular 8. The syntax changed a little. Before that, we had a system.js URL there. It's now a bit different. You're using import and then have to pass the module back. So that changed a little. Directly related to lazy loading are the so-called preloading strategies. Because now certain routes are being loaded. Sorry, per default, all routes are not being loaded. Only when you first access them, Angular will, in the background, download the module and then parse it, execute it, and so on. That's the default, called no preloading. It has an advantage because your application has a very low footprint when you first started, but it also has a huge disadvantage because if you are offline in the meantime, this part of the application can't load because we don't get the bundle. So that's why in some cases it may make sense to use the preload on modules strategy. That will automatically preload your entire application and all of the different lazy loaded modules at once after the launch. That leads to a still better loading time. Has the advantage that it's now being or can be run offline now, but of course comes at the cost of bandwidth. So the footprint is a little bit greater. That's how you use it. Just add the preloading strategy and then say which strategy you want when you are importing the router module for root. And if you like, you can also write your own preloading strategy and speculate on which routes the user may access next, so you can directly prefetch them, for example. Okay, next we have server-side rendering. I'm sure you've all heard of Angular Universal. What that tool does is pre-render your entire website using the exactly same sources that will later be transferred over to the client. And once Angular kicks in, it will then attach to the server rendered content. Currently that's supported for Node.js and ASP.NET Core. Here's an overview of how that looks. Comparable to AOT, we are compiling the view class on the back end, and we will also pre-render that index HTML. So that's already finished. It has all of the different DOM nodes that the client would have to render first. They are all handled by Angular Universal. And of course, this is great for SEO purposes, for preview links for social media, for graceful degradation. If you have users with IE5, then they may understand HTML at least, right? Also reduces loading time and is also good or great for mobile devices. All right, there's a little thing called web app gap, which is the following. Server-side rendering is great, but there's still some time until Angular kicks in. So there's a little library called preboot.js, and what it does is record your inputs, for example, on the server-side rendered content, and as soon as Angular kicks in, it will simply replay them on the then client-side generated content, which reduces the web app gap to this little asset downloads thing. And Johannes, only that last point. It's really short. I promise.
don't want to stress you. Just stay here, you know.
I promise.
Just before you switch the topic, maybe you can name some disadvantages of server-side rendering. Because so far it's like perfect.
Yeah, disadvantages of server-side rendering are the effort to get it working, and it has to work on your server environment, for example, and you have to have control over that server-side environment. If you have a large bank, for example, which says I only run IIS version 8 or something, right? Then you have a bad chance to get that running. All right, last point. Let me make it short. Service worker is something that is related to PWA. The service worker allows you to store responses on a cache, which is kept on the browser side. So the idea of the service worker is to never download the same resource twice. The advantage is you get an offline copy, so your application will also run offline. And when you access the website the next time, the contents are being read from the cache instead of over the wire. So that makes your application, just launch like a rocket, because you have all of the different required source files already in place. All right. If you want to do service workers, just run ng-add, as we've learned, at Angular PWA, and you're good to go, because that automatically attaches to your ngbuild --prod command. In the slides, which I will upload to SpeakerDeck afterwards, you will find that little cheat sheet which summarizes the different methods that we've seen in the first part for runtime performance. And for now, I'd like to thank you for your kind attention. Let's have some pizza.
Thank you.